I'm Jorge Sanchez, and I'm the group leader of one of the teams here in IFF Benicarló. And in our group, we are devoted to the research of organic synthesis. What we try to analyze or to study is to introduce new disruptive ideas in our potential or prospective production methods for our fragrance ingredients, because we want to add additional value to our products. So that could be not just a more efficient, introduce more efficient production method. Additionally, we would like to introduce more sustainable processes in our production methodologies. So we can attack these challenges in many different ways. One of them could be the use of different transformations, different pathways, the use of different reagents, different starting materials. So when we're putting all these together, we also need to consider what is the impact in terms of sustainability and carbon footprint when we're trying to identify which is the best possible way for or strategy to be applied. We use green chemistry principles when we are designing our potential processes. There are 12 principles in green chemistry. The reason why we introduce or consider the green principle in the development of new ideas, new methodologies, is because that way we ensure that our processes are more robust and also they bring more benefit, not just because of the product itself, but also because we are having like a wiser use of energy and resources, and we don't produce waste, or we try to reduce the maximum we can. In the case of VeraSpice, it is a very challenging material, because it is not when you analyze the structure, it's not just a single component, it is a mixture of different isomers, and all of the isomers, they have a specific or particular contribution to the final character and properties of the material. So in this case, in the original process of VeraSpice, this complex mixture was associated to the use of a specific catalyst. A specific catalyst that it is based on a precious metal, and that had all the disadvantages of a strong carbon footprint and also like a lot of instability in the market to ensure the production of the VeraSpice. So in this case, we were looking for alternative methods, considering the challenging of the problem. So at the same time, we were having a collaboration with one academic partner. They were using a different catalyst for a transformation that was comparable to the one that we wanted to study in VeraSpice. We worked together in doing a full analysis of each isomer, how they are formed, and with the use of their catalyst, they managed to tweak and to modify the process to get, in the end, with their catalyst, the same material, or a material that is comparable in properties and in analytics to our VeraSpice. This original difficult to source catalyst by another catalyst that it is much easier to supply, and also has a lower carbon footprint, and on the other hand, we also improve the energy usage and the waste production, or we reduce the waste dramatically with the new process while keeping really high selectivity. So the benefits come from the two perspectives. From the perspective of the supply chain, so we can ensure the production of the product and serve our customers, and on the other hand, to have a more sustainable and greener process. For being a researcher, you need to have the passion. There's always a challenge in life. In this case, you have the freedom of come up with all the ideas, to talk, to interact, to exchange thoughts with a lot of people, with the people in your team, with people in other teams, with people on other sides, on other countries, within the large organization that it is IFF. And in the end, it's like the beauty of seeing that your idea or an idea where you contributed is actually evolving and turning into something that is really finding an application that is really highly rewarding.